It's pajama day. I like that one. I was gonna start this with something else, but it's pajama day. It's a good beginning to this lecture. Alrighty. I said alrighty. I'm not supposed to say alrighty. I think 16. Yeah, so probably the points will be like 12 or something. Yeah. So, direct variation was something that was covered in chapter 2, and we didn't do it because I always say, oh, God, what a waste of time. But anyway, we'll go over direct variation, and then inverse variation is chapter 9. So what is direct variation? They are equations in the form y equals some constant times x. They are linear. They always have a y-intercept of 0. And examples of direct variation could be like y equals 3x, y equals negative 1/2 times x. Let's see, 2y minus 3x equals 0. Oh, well, why is this one direct variation? Oh, if I add 3x to both sides, I get 2y equals 3x. Divide both sides by 2, I get y equals 3x divided by 2, which is 3/2 x. So yes, that's direct variation. This k is called my constant of variation. So my constant of variation would be 3 and y equals 3x, negative 1/2 and y equals negative 1/2 x, and 3/2 and y equals 3/2 x. So k is the constant of variation. So let's say that, boy, which way do I say this? Hold on. Hang on. Okay. If I say y varies directly with x, and I tell you that y equals 10 and x equals 2, I can find the constant. So first we'll find k. Well, remember my equation is y equals k times x. Substitute in a y of 10 and x of 2. My constant of variation is 5. So my equation is y equals 5x. And then if I want to find y when x is negative 3, well, that'd just be y equals 5 times negative 3, better known as negative 15. Okay, so that's the simplistic part. Now we'll do inverse variation. That's direct variation. Y equals k times x. Inverse variation is of the form y equals k divided by x. K is still called the constant of variation. These are not linear. They're funny looking curves. We'll start graphing them tomorrow. Examples of this would be like y equals -3 over x, or y equals 2 divided by 5x, or xy equals 7. Oh, well, that doesn't look like y equals some number divided by x, but let's divide both sides of this equation by x, and you get y equals 7 over x. That's a 7. And so that looks like k over x, some constant, some number divided by x. So that one, yes, is also inverse variation. Okay? We can do the same thing with this that we did with direct variation. I asked the question, I said, y varies directly with x, and I gave you a couple of x and y's. So we'll say x and y vary inversely, with x equals 4 and y equals -3. First off, find k. So I have y equals k over x. Y is -3. So -3 equals k over 4. Multiply both sides of this equation by 4, and I get k is equal to -12. My equation of inverse variation is y equals -12 over x. And now if I want to find y if x equals -2, well, y is -12 divided by -2, which is 6. Okay. Now, how do I tell if something, you'll get some tables, and you'll be asked to tell if something is direct variation, inverse variation, or neither. So let's see how we do this. So I'll call this direct, inverse, or neither. So if I give you an XY table, with 1, 2, 3, 6, and 10, 20, let's see if this is direct variation. So if I use the point 1, 2, and find my k, so y equals k times x, which is 1. So in this case, k is 2. Does that hold true for the other 2 points? We'll take the point 3, 6. Oh, 6 equals k times 3. Oh, k equals 2. Yes, we have the same k. Also work for 10, 20? Yeah.